When we're talking about being able to be good consumers of research studies, one of the areas that we really need to attend to, and it has its own field, in fact, psychometrics, is how we're actually measuring the constructs that we're talking about. So, for example, if we say that anxiety has a strong relationship with relationship success, well, how is anxiety being measured? Is it a good measure? And how is relationship success of being measured? And it is a good measure. So we're going to take a kind of side tour, if you will, into a little bit of a deeper dive on how do we actually identify good measurement. And again, we're wanting to do two things in this chapter. We're wanting to talk about the methodology that we would use, but we also want to make sure that we're understanding that methodology so that we can interpret it when we read studies and we have the question, is this good measurement? So we're going to talk about types of measurement scales and types of ways to determine or to make an argument, if you will, that a measure is good. So the first thing we need to recognize is that there are different ways to measure variables. So when we talk about variables, we're generally in psychology talking about psychological constructs. In other words, there are things that make us unique and different. They're personality. They're things that we're having to infer, not necessarily directly measure. But within that, we have three ways that we can kind of generally measure a variable. The first one is self-report. We simply ask someone. Now, it may be as simple as a simple question, how depressed are you? Or it might be a survey or a series of questions that are meant to measure but are still self-report. How much do you agree or disagree with the following statements? And there might be 15 statements all on a 1 to 5 scale. So the higher your score, for example, the more depressed you are, the lower maybe the less depressed. And again, can vary depending on how the scale is set up. It might be the reverse, that lower scores mean more depression, higher scores mean less depression. But no matter what, if the actual individual is reporting either directly or indirectly through a series of questions, that's a self-report measure. We're inferring the variable by a series of questions. And again, we want to ask, what are those questions and what's the evidence that they are actually measuring what they're claiming they're measuring? The next one is observational. So we can observe people's behavior. So there's a lot of behaviors that are associated, for example, with depression. We may have people, and often this is still technically being reported by others, but it's no longer the person reporting, it's people observing the person. So it might be family members, it might be researchers, it might be an experimental setting where people are observing the number of behaviors. But no matter what, that's what it is. It's an observation of someone else's behavior. So we're no longer asking them to report how they're feeling or what their trait is. We're now observing and inferring. And the final one is physiological. Physiological means that there's actually a more objective measure, but usually speaking, physiological also gets further away. And you can kind of see that as we move from self-report to observational to physiological, we're often moving to a more trustable source, if you will. In other words, self-report has a lot of problems. Is the person lying? Does the person even know what their personality is or this particular construct is? Do they understand this? Someone might be technically diagnosably depressed, but actually self-report that they're doing fine. It depends on the scale and the person. Observation's a little harder because we're now, to fake at least, we're usually getting to where other people are watching the behaviors. But it's also further afield from inferring that actual construct. So again, the construct resides, if you will, in the person that's being observed. So again, we might observe behaviors, but from those behaviors, we're having to make that inference. So we might agree more often. For example, the person spent 15 minutes and three people agreed they spent 15 minutes in a depressive state. And we need to make sure we define depressive state. But does that actually represent the fact that they are depressed? And finally, physiological. We might actually look at blood pressure readings. We might look at brainwave patterns. These might also infer a difference. In other words, someone's depressed might have a lower blood pressure or a lower number of heartbeats per minute. But that could also be caused by lots of other situations. So as we move up the scale from self-report to observational and physiological, usually there's less and less disagreement, less and less error due to not understanding or due to maybe even lying or wanting to report something other than what the reality is. But at the same time, it also gets further and further away from being able to directly represent the construct. In other words, if I tell you someone had a lower heart rate, therefore I assume that they are depressed, you would probably have a bigger question about that. Not that whether or not they had a lower heartbeat, you'd accept that. It's more in the inference of what that means. So again, there's just a lot of different ways to measure the variables that we're interested in. So example, if we're measuring the construct of well-being, we can give someone a 15-item, 5-item scale. We might have a group of observers watch them to basically see how often they smile in a given situation. Or we might also brain scan based on the fact that people who we've already determined that various parts of the brain light up when people are typically doing well. So these are three types of operationalizations: the self-report, the 5-item scale, the observational, the number of smiles, and the physiological, the brain scan. Now, this is one of the reasons why truly trustable studies often are very invasive. In other words, if we were going to use all three methods in a single study where the person's being brain scanned, they're filling out a self-report, and we're getting information from either researchers or family members observing this behavior, that would give us a better feeling, especially if all of these measures concurred with each other, that we are indeed getting at well-being. But at the same time, that might be an exhaustive study. We might actually have a series of studies, one of them that uses an observational outcome of well-being, one of them that uses a self-report, and one of them that uses a physiological. So these can be used in conjunction or separately, but their use separately often is being driven by fatigue of the person that's being evaluated, but also just the reality of doing individual studies. Next, we have the scales of measurement. So the first thing we want to ask is our scale categorical or quantitative? So basically, there's really four types of scales, but the first question is it categorical, the first type, or is it quantitative? And if it is quantitative, we need to ask additional questions. So categorical scales are simply categories. The numbers have no real meaning other than labels. So one of the ways to think of a categorical scale is the numbers are just labels. So for example, if I say I measured males, females, or people that reported something other, or non-binary, that would be three categories. I could number that males 1, females 2, non-binary 3. Or I could completely change that around and make males 3, females 2, and non-binary 1. The numbers have no meaning. 1 doesn't mean that you are the best. 3 doesn't mean you're 3 times more of a quantity. It simply is a label for the purposes of our statistics. So when we do statistical analysis, we need to put everything into numerical information in order to run the math. Therefore, categorical data simply means that it's categories. The numbers have no meaning. If it's quantitative, the numbers have some form of meaning. We then have three types of quantitative scales: ordinal scales, interval scales, and ratio scales. So in ordinal scales, there are meaningful values, but there's unequal intervals between the units. So think of this as first, second, or third place. So someone that won a race is first place. The person that came in second is second place. The person that came in third is third place. That gives us some information. That gives us the order that people were in. And it means the numbers have meaning. First is better than second. Second is better than third. But what we don't know is what was the actual time difference, for example. So ordinal scales have some value. They're the first type of quantitative scale, but all they give us is ordinal information. They don't tell us about what the intervals are. In other words, what's the difference between first and second? So for example, someone might actually, for example, we're going to use weightlifting. Someone might lift a deadlift of 450 pounds and was first place in a particular lifting competition. The person that was second might have lifted 449, so 1 pound difference, or they may have actually been way below. They might have been 375, so a 75-pound difference. We just don't know. Interval scales are typically used when we're measuring psychological constructs. It basically means that there is a supposed equal interval between units, but no meaningful zero. So what this means is that we're putting things on a scale. So your typical Likert scale of 1 to 5, 1 being strongly disagree, 5 being strongly agree, that would be an example of an interval scale. The idea is the difference between 1, 2, 3, 4, and 5 are approximately equal. Now, we don't know this for sure, and how people might interpret this may be slightly different, but for the most part, we can assume that we have these equal intervals. And that's important for a lot of our statistics and a lot of our math that we're going to be doing to analyze various scales. So generally speaking, if you have a choice between an ordinal scale and an interval scale, you're going to want to go to interval. The problem with interval scales is there is no meaningful zero. In other words, that's why I said these are typically used to measure psychological constructs. Depression, no one is going to be a zero. They have no depression. Zero is not necessarily meaningful. And also, the numbers are relatively, other than equal interval, they're again just labels. So, for example, my interval scale might be 1, 2, 3, 4, 5. It might be -2, -1, 0, +1, +2. Notice there's a zero there, but it's not a meaningful zero. It could easily be also 100, 200, 300, 400, 500. Or I could flip it. It could be 500, 400, 300, 200, 100, or 5, 4, 3, 2, 1. So we need to know the direction and the meaningfulness of those numbers and how they're actually representing them. Is higher numbers more of something, or is higher numbers less of something? Those are important questions we want to ask when we've identified an interval scale. Now, ratio scales again add another component, equal intervals and a meaningful zero. So generally speaking, this is count data or time data for the most part. There are other ratio scales, but the first question you can ask is, does zero actually mean nothing? It means zero of the thing. So for example, if I'm counting the number of times someone blinks and in a 10-minute period they never blink, zero blinks is zero. Zero means zero blinks. And the equal intervals come naturally then. So one blink is 1/2 of 2 blinks. 10 blinks is 10 times more than 1 blink. So we have no equal intervals and a meaningful zero. These are generally the best types of statistical measurements. If we can do ratio, we should always try. And basically that's the way this goes, is categorical. There are some variables that have to be categorical. If we're looking between group 1 and group 2, that's categorical. However, the outcome, generally speaking, we use ordinal data when we don't have anything else, or there's no other way to measure it. We're going to use interval data if possible, and if we can get to ratio data, that's kind of the gold standard we're looking for. But again, not all things can be put into ratios. So for example, if I'm measuring depression, there really isn't a way to do a ratio scale of depression, especially with either observational, well, again, we could maybe do count data, but definitely with self-report. So let's just take a quick look at learning activity. And basically, so for example, eye color. I'm going to give you a moment. I would suggest you pause for a minute and come up with your own answers for these 8, and then I'm going to briefly go through them. So here's your chance to just pause this video and take a look and think with each one, is it categorical, ordinal, interval, or ratio? Okay, let's talk about them. So eye color. Eye color would be categorical data. There is no meaningfulness. I could say brown is 1, blue is 2, green is 3, or I could put those in any other order. Ratings on a well-being on a 5-point scale. So again, on a 5-point scale, assuming things were done correctly, that's going to be an interval scale. Reaction time at a computer task, how long it takes in time, that's going to be a ratio scale. Order of finishers in a 5K race, again, that's going to be ordinal. All we know is the order. Parents' marital status, whether they're married, divorced, or not married, that would again be categorical. The numbers are just labels. Blood alcohol content, it would be possible to have 0. 0 is meaningful, that means no alcohol. This would be a ratio scale. Degree of pain felt as rated on a 10-point scale. Again, assuming that 10-point scale is rated correctly, this is going to be interval data. Seating order in an auditorium. So in other words, where you actually seat in an auditorium. This is probably going to be, again, categorical. There's some arguments that could be made in other directions, but in this case, if it's basically just labels. You are number 72. Well, what if the seats are changed around to where we're going from the top to the bottom or the bottom to the top? The numbers really don't necessarily have meaning in this case. So hopefully this gives you an idea of kind of looking through the idea of identifying whether a variable is categorical, ordinal, interval, or ratio. And again, ordinal, interval, or ratio is considered quantitative scales, while categorical data is kept separate. So basically, when we're looking at a measurement scale, there's a lot of things we can do. We can look at construct validity. We can also look at reliability. And reliability is what I want to look at first. So this is a pretty complex table, but it basically has everything that we're talking about here. So reliability is necessary, but not necessarily sufficient for validity. So when we talk about validity, remember, we're talking about the truthfulness. Are we actually measuring what we claim we're measuring? Reliability is a little subset that doesn't actually ask that question. It doesn't ask, are we measuring what we're measuring? It simply asks, are we actually measuring the same thing, whatever it is, each time we measure it? So reliability, do you get consistent scores every time? And there's a big question here for reliability. Now, again, most of what we research in psychology is something that is considered to be consistent or stable over time. So if someone is generally depressed, they're going to be depressed most of the time. If someone is generally happy, they're going to be happy most of the time. If someone's outgoing, they're going to be outgoing most of the time. So we'd expect to see fairly similar scores at different times. If what we're actually measuring is something that might vary greatly from measure to measure, reliability is not going to be as useful of a tool. So we're going to briefly talk about three kinds of reliability. Test, retest reliability. Basically, people get consistent scores every time they take the test. So if I give someone a 15-item measure of well-being, and then I give it to them again 3 months later, do I get very similar scores? Internal reliability, people give consistent scores on every item of a questionnaire. So if I have 15 items that are all meant to be measuring the same construct, do I actually see relatively stable responding? In other words, if someone is responding high on a lot of items, do we see that pattern? If someone's scoring low on a lot of items, do we see that pattern? What we don't want to see is someone scoring high and low on very similar items. And finally, we have inter-rater reliability. This is, again, more for observational data. When multiple coders are watching for the behavior, do we actually see ratings on a set of targets are consistent with each other? In other words, do we see consistency in those raters? So let's talk about each one of these a little bit more in detail. So again, we have three ways to measure reliability. And reliability is simply asking, are the scores consistent? So this isn't answering whether or not we're measuring what we think we're measuring or what we're stating we're measuring. It's simply, are we measuring something that is consistent? So again, there's test, retest, inter-rater, and internal validity. And we'll talk about each one of these in a little more detail. And it's going to get a little complex here as we go on. So test retest reliability is probably the most simple. It is generally, do we get consistent scores every time we test? And again, there is an assumption here that the construct that we're measuring is relatively stable. So we should see fairly stable results. Again, does the concept fixate or does it fluctuate? And think about this in general, like with tests in a class. If I gave you the same test 3 times over 3 different weeks, I would expect people that did well to do well all 3 times. I'd expect people that do poorly to do poorly over all 3 times. Now notice there is going to be some problems here. So if you did poorly on a test, you might actually go back and study a little bit, especially if you knew you were going to take the test again. So there may be some fluctuations, and we're not expecting a perfect relationship, but we are expecting there to be somewhat consistency. And we'll talk about how we actually analyze that statistically in a minute. Inter-rater reliability is basically consistent scoring no matter who's rating. In other words, are observers one's observations equal to observer two? We see this a lot in sporting events, specifically boxing and figure skating, for instance, where there's a series of judges. We're hoping that those judges are seeing the same fight and are looking at the same observations. And in fact, a lot of times when the judges are not necessarily consistent is when there is a question of what was going on. So generally speaking, if we're doing observational data, we're usually wanting at least 2, if not 3 researchers to be grading those observations. And are those observations consistent? In other words, if researcher 1 said they saw someone blink 5 times, does a researcher 2 and researcher 3 agree? Now, they may not perfectly agree. In fact, you might get 5, 4, 6. But there should be a consistency. What you wouldn't want to see is 5, 0, 10. That would be an example of inter-rater unreliability. And finally, we have internal reliability. And this can be basically, we don't want to confuse this with validity. Again, reliability is about simply, are we getting reliable results? Not necessarily are we measuring what we think we're measuring. It's the extent to which multiple measures or questions or items that are answered by the same set of people are consistent in their responses. So we'll just take a quick look at this one. In most ways, my life is close to ideal. The conditions of my life are excellent. I am fond of polka dots. I'm a good swimmer. I could live my life over. I would change almost nothing. Now, those first ones, 1, 2, and 5, probably we would expect to see a high internal consistency. If you answered on a 1 to 5 scale that you agreed strongly with most ways my life is close to ideal, the conditions of my life are excellent, and if I could live my life over, I would change almost nothing, we'd expect someone that's got high well-being, for instance, to basically answer all 3 of those with 4s and 5s. If someone was actually struggling with their life, in most ways, their life was not close to ideal. The conditions of their life were not excellent. And if they could live their life over, they'd change a lot of things. We might see 1s and 2s there. So again, that'd be internal consistency. Now, I'm fond of polka dots. We would not expect to see a higher amount of consistency. And in fact, if we analyze this statistically, we'd expect 3 and 4 to probably be measuring something completely different or unrelated. So again, when we're looking at a scale or a set of items, we're wanting to see that they're asking similar questions that people would respond similarly if that construct was actually what's being measured. When we talk about inter-rater reliability, we're actually, again, talking about consistency, no matter who's rating. So, for example, if we're looking at Matt's ratings versus Mark's ratings, we'd expect to see a very high correlation. So this is just a chart that shows how people are being scored. So, for example, if we look at Jay, Jay is being scored a 9 by Matt, and he's being scored a 9 by Mark. So we have a strong reliability. If we look at Jackie, we see that Mark's rating her as a 2, but Matt's rating her as a 3. So it's not perfect, but we can see that relationship. Now, if we took a look at that second option, we're seeing a lot more variance in there. So, and also this would show up statistically. So, for example, if we look at Mark and Peter's rating, we see that Mark has rated Jackie as 2, but Peter has rated her as a 7, whatever this behavior is. And again, when we look at Jay, we see a little more consistency. We see that Mark has listed her, Jay, him or her, or whatever that pronoun is, as a 9, while Peter has rated that person as a 6. So again, what we're looking for is a strong level of consistency statistically. Now, does that mean that Mark and Matt are rating the actual what we're claiming they're rating? Not necessarily. It simply means that they're consistently seeing the same information. So internal reliability asks for consistent scores no matter how you've asked those questions. And there's 2 ways we can look at this. We can simply look for the correlation, and that's what we were looking at in the last slide. A statistic that represents info in that scatter plot. It basically sums it down to a number. Generally speaking, that number is going to be negative 1.0 through positive 1.0. And the negative versus positive simply means what direction it's going. Is the relationship a positive one, as one variable goes up, the other one goes up as well? Or is it a negative one, as one variable goes up, the other one goes negative? So if we're looking for internal reliability, we'd want that number to be positive and as close to 1.0 as possible. So for example, if we had 2 sets of raters and one of them had a correlation coefficient of 0.9, pretty close to 1.0, that person would that set of internal reliability would be higher than if we had 2 people and their correlation coefficient was 0.5, a little further away. And in fact, if we go back to that previous slide and take a look at those 2 examples, the first example is probably an example of a correlation of about 0.9 or higher. And the one after it is probably still a correlation. There was some relationship, just not as strong as one. That would probably be a 0.4 or 0.5. The other statistic we can look at is the Cronbach's alpha. It's the average of all possible intertotal correlations. So basically, it takes the correlation coefficient that we just talked about, which is basically comparing 2 items, and it averages them across a whole series of items. So if you had 15 items, the Cronbach's alpha would look at item 1 and its correlation with item 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And item 2 with 1, 3, 4, and you get the idea. So it's an average of all possible inter-item correlations. Generally speaking, when we're talking about internal reliability, we're often going to report the Cronbach's alpha, especially if the scale has multiple items. And here's some examples of various things. So estimates of internal consistency and temporal reliability of the satisfaction with life scale. So this is different people's studies, but what they're reporting. And the Cronbach's alphas basically range between 0.79 and 0.89. So that kind of gives you an idea. By the way, the scale often used to determine if a scale is good, generally anything over 0.7 is considered decent, anything over 0.8 is considered solid, and generally if you're going to be making decisions based on a scale, you want to see 0.9 or higher. So is the life scale a good scale? For the most part, yes. Is it a great scale? Not necessarily. So the next thing we're going to talk about is construct validity. And there's two ways to look at construct validity. There's two subjective ways, and there's three empirical ways, and we're going to talk about all five of these. So the two subjective ways, subjective basically means there's no statistics behind them. So there's face validity and content validity. This is basically a personal call, and we'll talk about that in the next slide. And then there's three ways to empirically test construct validity. We can look at criterion validity, construct convergent validity, and discriminant validity. So criterion validity is is your measure correlated with its relevant outcome? So for example, if I have a well-being scale, does it also measure with correlate highly with a life satisfaction scale? Convergent validity, your measure is more strongly associated with measures of similar constructs. And discriminant validity is your measure is less strongly associated with measures of dissimilar constructs. So these are different ways that we can start getting at, are we actually measuring what we think that we're measuring? So the first two are subjective. Face validity, does it look like a good measure? Often asked by asking experts. In other words, does it look like it's actually measuring whatever it's supposed to measure? If it's a measure of life satisfaction, do these questions look like they're measuring life satisfaction? Now, face validity is interesting because for most things, we want high face validity. If we're using a measure that's going to be measuring, for example, extroversion, we want people to look at it and go, okay, this looks like a measure of extroversion. The problem with that is that it does allow people to decide, do they want to be perceived as more extroverted? I know personally when I take personality tests, especially for a job interview, I often ask myself, what are they likely to be looking for? And how do I want to answer these questions in a way that may skew it a little bit more high? In other words, generally speaking, if I'm looking at a job that is going to be working by myself, I'm probably going to be reporting more introverted behaviors. If I'm applying for a job that I know will be involving working with teams, working with others, and getting along with people, I probably want to be perceived as a little more extroverted. So these are not gross changes, but it does mean that I'm playing the scale a little bit based on face validity. So there are some scales out there that actually purposely are low in face validity. They don't look like what they're measuring, what they say they're measuring, but they actually have been proven through other techniques to be doing that. The next one is content validity. Does it include all the important components of the construct? So you kind of think about, if I'm thinking about life well-being, what all is involved in life well-being? We might actually create kind of a pool of items. And we might actually sit there and think through which of these pools do we need to make sure we're asking questions at to fully understand this construct. So this is one of the areas that, again, are usually being done by experts or people that are familiar with the actual construct, and basically can also be looking at past research to define the operational definition. What is the operational definition or the construct definition of the measure or the construct that we're interested in measuring? And then, do we actually have all of the content represented in the questions that we're asking? So this is two ways that we can just take a look at a scale and ask, does it have face validity, and does it seem to cover all the contents of the construct under review? The next thing we're going to look at is actually ways to actually statistically determine. So basically we have criterion validity. Does it correlate with directly observable behavior? We see this a lot in actual employment measures. So for example, if we have a sales ability test score, we give everyone that's applying to a sales position a test that basically is meant to measure their sales ability. But for those that are hired, we then look at how they scored on that test versus how many sales they actually make. And this would be an example on the left of a very strongly criterion validated scale. We're measuring sales ability, and an outcome that we'd expect to be strongly related, the actual amount of sales, is strongly represented. So again, we can look at, for example, Arena scored almost 100% on the actual sales ability test score and is selling over $100,000 worth of sales and is the top salesperson in her class. We're looking at Alex, who scored a 40 on the test and is also only making 40,000. Now, we might also then look at something like IQ score. So IQ might simply be some measure of cognitive ability. And again, we're probably going to find a relationship, but it may not be as strong a relationship. In other words, there's some people that may struggle a little bit with cognitive ability, but are actually really good at sales. And there's some people that might be very good at cognitive ability, but aren't that great at sales. It's two separate skill sets. Now, is cognitive ability a part of sales? Most likely. But at the same time, it's not the only part of it. So again, we're seeing a greater spread. We're seeing not a stronger correlation, and there'd be less criterion validity. Another way to look at criterion validity is to simply compare our measure versus a known group. So for example, we might look at depressed versus not depressed based on psychiatric judgments, and then see how they score on the BDI, for instance. This might also be an example of a criterion validity study. With convergent and discriminant validity, we're basically looking, do other measures that assess the same construct, are they highly related with our new construct? And divergent validity, other measures that do not assess the same construct or not as strongly measure it, or maybe it's not directly related, do we see a weakening? So generally speaking, again, if we have a study that's looking at convergent validity, we'll be using our new scale versus a known or existing scale to see if there's a strong relationship. So for example, here we have the CESD total score, which is basically measuring physical, or basically how overweight or not overweight based on medical model someone is, versus their BDI. They're basically, again, their total body mass index. And we see a pretty strong relationship. Not a perfect relationship, but a pretty strong one. This would be an example of convergent validity. But if we took that BDI score and compared it to physical health, notice there's still a bit of a relationship, but there's also a lot of noise here. It's not a strong relationship. That might be an example, for example, of divergent validity, where the two things are not necessarily associated as strongly. So this is a good time to briefly kind of go over, now that you have this kind of general overview of not only how we're just testing reliability and validity in scales, but also the ways to conceptualize scales, what we're doing, what I'm hoping for you to do in Chapter 5's assignment. For scenarios 1 and 2, you're simply going to report what kind of reliability would need to be evaluated, and then draw a scatter plot or describe the result that would indicate the measure has good reliability and one that shows it has poor reliability. So basically, you're going to be using examples that we just went through. So if it's a scatter plot showing good reliability, we're going to have two measures that are highly related. And if we have one that's poor reliability, it's going to be much less highly related and maybe not even have a relation at all. And also, what kind of reliability would you need to evaluate with each one of these? So that's what you're going to be doing in scenario 1 and 2. And again, think about the types of reliability we've talked about: convergent, divergent, etc. So the next one is scenario 3. How might you show this measure has criterion validity? How might you show this measure has convergent and divergent discriminatory validity? And again, we're going to be looking at that as well. So scenario 3, you're going to be looking at a measure and tell me how you define criterion validity. In other words, how well it relates or doesn't relate to others, and then how would you actually conduct a study to look at these differences. So again, a highly related scatter plot is going to be like the first one. A very unrelated scatter plot is going to be like the second one. So let's review interpreting construct validity evidence. So this is just an example of a measure of religiosity. And again, we can take a look at this as far as what has actually been reported. So this is more about how do we actually look at a scale. So the first thing we can do is we can simply look at the scale and go, does it have face validity? Does it look like it's measuring religiosity? And then content validity. If we're measuring religiosity, what would be important to ask, and are all of these areas being covered by these 10 questions? Then we can actually look at the text in the article itself to determine what they did. And they actually report a Conbrax alpha for this new scale was 0.93 for the full scale. So in other words, this 10-item scale was highly related, correlation of 0.93. Again, the best correlation you could ever get is a perfect correlation of 1.0. So 0.93 is pretty strong with the much larger scale. They also included a test-retest reliability information. They basically gave the people the test and 5 months later gave them the test again. And they found this was also high. They found a correlation of 0.84. I would also want to know what the actual Conbrax or the Conbrax alpha or the coefficient or the Conbrax alpha is of this scale. So how well is it internally connecting? That is not necessarily given, but that might be another thing you'd look at. And then within that same article, we actually look at what they're reporting here, and we actually see some information about discriminatory and also confirmatory analysis. So again, we look at how the actual full scale, what people's ratings were based on their denomination or type of religion. So notice Protestants, 37.9. This is that yellow box. People that reported no religiosity, 22.3. Those that were Roman Catholic, 30.1. And those that reported some other religion, 27.6. So we'd expect the people that reported no religion would score lower than people that reported a religion. And we do find that. So that would be an example of basically a known group comparison. We're also looking at how it actually correlates with attendance at church, a single item measure of religious commitment, and the intensity of spiritual life scale. And again, this is that gray box. We see 0.76, so there was a strong correlation between how high people scored on this particular religiosity scale and their attendance at some form of worship. When they single item reported how religious they were compared to this scale, 0.82, and comparing it to another intensity of spiritual life scale, an existing scale, 0.66. So again, this is not necessarily groundbreaking evidence. I would want to see 0.9s across the board here. I'd like to see even a bigger difference between those that are reporting religion and those that are not. But it does provide some evidence that there is support that they're measuring what they're claiming they're measuring. And that's what we're really looking at whenever we look at a scale. Is it actually measuring what they're claiming it's measuring? And is it measuring it reliably in a way that is statistically consistent?